This is my second clip on trigonometry, a difficult topic, but I suggest you might want to watch my first one on calculating the angle of a right angled triangle first. I'm going to use this as an example. I'm going to say that theta here is 37 degrees, and I know the size of the hypotenuse as 5. I'd like to use this information to calculate the length of the other two sides. This is the opposite side, this is the adjacent side to my angle theta. So to calculate the opposite side, the length of this opposite side, I could use the hypotenuse and the opposite side, and that would use the ratio of sine. So the sine of theta is still equal to the opposite side over the hypotenuse, and the information that I have, I don't know the opposite side, but I do know the hypotenuse of 5. I also know that theta is 37 degrees. So my information is now the sine of 37 is equal to the opposite side over 5. I now use my calculator to find the sine of 37 degrees, and that is simply 37 and the sine button. So the sine of 37 degrees is equal to 0.6. I'm now going to use my balancing the equation method just to have the opposite side on its own. So I'm going to multiply both sides by 5. That will disappear. So my opposite side is equal to 0.6 times 5. And that gives me a final answer of 3. So I can now use my ratio of cosine to find the final length of the adjacent side. So the cosine of theta is equal to the adjacent side over the hypotenuse, and that is equal to the adjacent side over the hypotenuse, which is 5. Clever bit again, using a different model calculator. With this calculator you press your cosine button first, then your 37, and that will equal 0.8. So the ratio of the adjacent side over the hypotenuse, which is 5, is equal to 0.8. Again, using my balancing the equation method, I'm going to multiply both sides by 5. That goes to 1. Multiply that by 5, and that will give me my adjacent side, which is equal to 4. I hope that helps.